This is a dissolved oxygen question in the topic of water. It's the 2019 question 1. Okay, a concentration of at least 5 ppm of dissolved oxygen in a water system is required to support a large and varied fish population. The dissolved oxygen concentration of such a system was determined as described below. A stoppered bottle completely filled with a sample of water was shaken with a concentrated solution containing manganese 2+ ions and then with a concentrated solution of alkaline potassium iodide. The dissolved oxygen oxidized some of the Mn2+ ions to Mnx+ ions. These Mnx+ compounds appeared as a brown precipitate. When a small volume of concentrated sulfuric acid was then added, all of the Mnx+ ions oxidized some of the I- ions to free iodine, I2. The concentration of the free iodine was measured by titration with a standard solution of sodium thiosulfate using freshly prepared starch solution as an indicator. Now we're given the balanced equation for the titration, and we note the reaction ratio between iodine and thiosulfate is 1:2. So that means I'm using double the number of moles of thiosulfate than the number of moles of iodine. We're also told that 4 moles of sodium thiosulfate were required for every 1 mole of dissolved oxygen originally present. Okay, so that again is an important molar ratio that we'll use in our calculations later. So just taking a look at our theory questions A, B and C. Okay, you can pause the video and you can check the answers here. Okay, so just pause the video and you can go through the solutions to parts A, B and C on the video here. Okay, let's focus on the calculation part D now. Okay, so we are asked, or we are told, that the sodium thiosulfate solution contained 3.1 grams of sodium thiosulfate per litre. Okay, on average 6.0 centimetre cubed of this solution were required for complete reaction with 200.0 centimetre cube portions of the iodine solution. So we should be underlining or highlighting the important information in this section. Okay, so we're asked to show by calculation that the dissolved oxygen levels were a threat to fish survival in this water system by finding the following. Okay, so we're asked first of all to find the average number of moles of sodium thiosulfate used in a titration. Okay, so in order to answer this part and all of the other parts here in the calculation, we need to set up a table. Okay, so the 3 chemicals that we're kind of dealing with here in this experiment are oxygen, iodine and thiosulfate. Now we were told in the question that the molar ratio between the thiosulfate and oxygen was 4:1. So we have 4 times the number of moles of sodium thiosulfate for every 1 mole of oxygen. And we're also told in this titration reaction that we have double the amount of thiosulfate than we do free iodine, I2. So let's write that into our table. Okay, so for every 4 moles of sodium thiosulfate, we have 1 mole of oxygen. Okay, and from our titration equation, it said that for every 2 moles of thiosulfate, we have 1 mole of iodine. So that's saying that we have double the number of moles of thiosulfate than we do iodine. So that's why we can put a 2 here. Okay. Now, the first thing we're asked to do was to work out the average number of moles of sodium thiosulfate used in the reaction. Okay, so we were told that we had 3.1 grams of the crystals, the sodium thiosulfate. Okay, so we need to work out, and that's in per litre. Okay, so we need to work out how many moles that is. So the first thing I'm going to do is I'm going to work out the relative molecular mass of sodium thiosulfate. Okay, so I need to write this out. I don't just do it on my calculator and write down the answer. I need to show my workings. So I have 2 times sodium. Okay, so the relative atomic mass of sodium is 23 from my periodic table. Okay, 2 times 32 for my 2 sulfurs. 3/16 for my 3 oxygens, and 5/18 because water is made up of 2 times 1 for hydrogen and 1/16, so that's 18 in total. Okay, so 5/18s. So when I add all of that up, I get 248. Now, using my good night Mr. Tom triangle, I'm trying to find the number of moles. So number of moles is grams divided by relative molecular mass. So for us in this question, it's 3.1 grams divided by 248. So we have 0.0125 moles per litre because the 3.1 grams were dissolved in 1 litre of solution, okay? So our final answer there, okay, so is 0.0125 moles per litre is my concentration of my sodium thiosulfate, okay? Now back to the question. What was I asked again? I was asked to find the average number of moles of sodium thiosulfate used in the titration. Okay, so let's go to our table. And we're just going to fill in the information that we just worked out there in rough work. Okay, so in our table we have molar ratio at the top, and then we have number of moles, we have volume, which must be in litres, and concentration in moles per litre. So I've just worked out the concentration of my sodium thiosulfate. From down here, it is 0.0125 moles per litre. Okay, what else was I told in the question? Well, I was also given the facts that we used 6.0 centimetre cubed of this thiosulfate solution, and this required 200.0 centimetre cube portions of the iodine solution. Okay, so let's write in that information. Okay, so we had 6.0 centimetre cubed portions was my titration value for my sodium thiosulfate. I need to convert that into litres, so I need to divide that by 1,000 to convert centimetre cubed to litre, so I have 0.006 litres. Okay, now I was told that I had 200 centimetre cubed volumes of my water sample, so I could write that in for both my oxygen and my iodine. Okay, so when I convert that to litres, that's 0.2 litres. Okay, now, so let's see, we want to work out in D part 1 the average number of moles of sodium thiosulfate used in the titration. So we'd like to fill in this box here, okay? So we want to work out the number of moles, okay? Now, I'm going to use my handy little triangle, my not very complicated triangle, okay? If I want to work out the number of moles, I cover number of moles, okay? And I'm left with volume times concentration. Okay, so let's work that out up here. So to get the number of moles, it's volume times concentration. My volume in litres I have already 0.006 litres, and the concentration I worked out earlier, 0.0125 moles per litre. So when I number crunch that, I get 7.5 by 10 to the minus 5 moles. Okay, all right, so this number is 0.4 zeros, so 0.000075 moles. Okay, I've written it here in scientific notation. Okay, now, so we've answered part 1. Okay, so part 1 from section D was to work out the average number of moles of sodium thiosulfate used. So let's write that in down here. So that's my 7.5 by 10 to the minus 5, don't forget your units, moles. Okay, so what do I want to know next? Well, I want to know the number of moles of oxygen that released the iodine detected in each titration. So back to my table. I want to know the number of moles of oxygen. So I know from my molar ratio that I have 4 times the number of moles of sodium thiosulfate than I do water. So simply what I do is, sorry, not water, oxygen I should say. So simply what I do is I take my number of moles of sodium thiosulfate and I divide that by 4. So to work out the number of moles of oxygen, okay, I'm going to divide the number of moles of sodium thiosulfate, 7.5 by 10 to the minus 5, divided by 4, and that will give me 1.875 by 10 to the minus 5 moles of oxygen. So I can write that in now as my answer for part 2. So the number of moles of oxygen dissolved in the water is 1.875 by 10 to the minus 5 moles. Alright, so next I want to find the concentration of this dissolved oxygen. So I need to convert from moles into moles per litre. So let's go up to my table once more. Okay, so I have my number of moles. I know my volume was 200 centimetre cubed, which is 0.2 of a litre. So to work out concentration, again I go over and use my not very complicated triangle. To find concentration, it's number of moles divided by volume. So concentration is number of moles divided by volume. So for us, number of moles is 1.875 by 10 to the minus 5 divided by 0.2 litres. And that works out to give me a concentration of 9.375 by 10 to the minus 5. And my units are moles per litre. So I can write that in now. So my concentration of dissolved oxygen is 9.375 by 10 to the minus 5. Or very simply, you could just write a little 3 here beside D part 3 beside that answer if you want. But I think it's nice just to write it all out at the bottom. Okay, my very last question now is I need to find the concentration of dissolved oxygen in ppms. So I have the concentration in the units of moles per litre. I want to convert to ppms, okay? So we all know that 1 ppm is the same as 1 milligram per litre, and a milligram is 1,000th of a gram, okay? So I would like to convert my moles per litre into grams per litre first, and then I can convert into milligrams per litre. Okay, so in order to do that, I'm going to need my Goodnight Mr. Tom triangle. Okay, Goodnight Mr. Tom. If I want to work out grams, I need to take the number of moles and multiply by the relative molecular mass. Okay, so with oxygen, okay, the number of moles I have is my 9.375 by 10 to the minus 5. Okay, so just reminding myself over here to find the number of grams, I'm multiplying number of moles by relative molecular mass. So for oxygen O2, we have 2 times 16, which is 32. So when I multiply 9.375 by 10 to the 5 by 32, I end up with 0.003 grams per litre. And I now want to convert that concentration into milligrams per litre. So I need to multiply by 1,000 because there are 1,000 milligrams in 1 gram. So I end up with 3 milligrams per litre. And we all know that a milligram per litre is the same as a ppm. So this is 3 ppm. Final answer, which indeed is lower than the 5 ppms of dissolved oxygen, okay, that the fish need to survive. Okay.